when a game theory and Nash equilibrium. Let us consider a duopoly market in which there are two firms in the market, firm 1 and firm 2. They are selling identical product. So, in this case, there are two possibilities. To be precise, there are three possibilities. Number one is that they can individually try to maximize profit. Number two, they can make a contract between these two. That means which one is, that means competition. That means they will not cooperate to each other. Another is forming a collusion. That means both will join hand and they will act as a multi-plant monopolist. So this is cooperation and cooperation. And third possibility, the worst possibility, is that one is cooperating and another is cheating. So let us start from the first possibility, competition. So whenever we are considering competition, we will consider that conjectural variation is zero. That means if one firm or one player changes its strategy, it will consider that his change in strategy will not be followed by his rival. But whenever his rival will be taking any stance or changing any strategy, this person will follow that. So this is called conjectural variation is zero. That means I am not expecting any retaliation from my rival. So now let us consider a simple demand function. The price equals to A minus. The demand function is P equals to A minus Q. Q stands for total quantity sold in the market. And here Q will be equals to Q1 plus Q2. Q1 is the output sold by first firm and Q2 is the output sold by second firm or second player. Let us consider, we are start with the symmetric cost. Symmetric cost, in which we consider marginal cost of production is constant and this is equal for both firms. C1 equals to C2 equals to C. So now let us consider the profit function. Profit function of R1 will be given as price into revenue, price into output, this is the revenue function, minus cost function. So we can write Q into A minus Q1 minus Q2 minus CQ1. And similarly, pi 2 equals to P into Q2 minus CQ2. It will be Q1, it will be Q2 into A minus Q1 minus Q2 minus CQ. So let us consider the first order condition. So what we will do? The objective of firm 1 is to maximize pi 1 with respect to Q1. We will consider Q2 as given, as conjectural variation is 0. And second firm will try to maximize this profit with respect to Q2, considering Q1 as constant. So the first order condition requires 0, that implies A minus 2Q1 minus Q2 minus C equals to 0. Now here we can write that 2q1 equals to a minus c minus q2. q2 equals to, or q1 equals to a minus c minus q2 by 2. This is called reaction function of form 1. Now let us consider the second order values. So del pi 1 del q1 del pi 2 by del q2 equals to 0. That implies a minus q1 minus 2q2 minus c equals to 0, or q1 equals to a minus c minus 2q2. This is called reaction function of form 2. Now from reaction function there are two unknowns and two variables, so we can solve it. So a minus c minus q2 by 2 equals to a minus c minus 2q2. Or here by solving, so if we take in right side 4q2 minus q2 equals to 2a minus 2c minus a plus c, so 3q2 equals to a minus c, and hence q2 equals to a minus c by 3. So now if we plot the value of q2 in any of the reaction functions, we will find the value of q1. So q1 equals to a minus c minus 2 into a minus c by 3. So it will be also equal to a minus c by 3. What will be the price now? So P equals to a minus q1 plus q2. So it will be a minus 2 into a minus c by 3 equals to 3a minus 2a plus 2c by 3, or equals to, it will be a plus 2c by 3. So form 1's profit will be given as P minus C multiplied by Q1. So A plus 2C by 3 minus C multiplied by A minus C divided by 3. So it will be equals to A minus C by 3 multiplied by A minus C by 3. So it will be A minus C whole square divided by 9. So automatically the profit of farm 2 will also be equal to A minus C square by 9. So both firm will be enjoying same profit if they are not cooperating with each other and they are acting as the competitor of each other. So both profit will be equal A minus C square by 9. So this is a follower-follower model. So both are rival firms and they are following each other. That's why they will end up with producing same amount of output. Now the second possibility is that if they form collusion. So if they form collusion, so they will act as a monopolist and then divide. Then they will try to maximize profit equals to A minus Q into Q minus CQ, minus CQ with respect to Q. So first they will find out the equilibrium level of output in the market, then they will distribute it among themselves. So here, so first let us consider the profit maximizing level of output. So it will be d pi by dq, first order derivative will be 0. So we can write that A minus 2q minus c equals to 0, or 2q equals to A minus c, q equals to A minus c divided by 2. And what will be the price? Price will be, so first if it q equals to, so every firm will produce q1 equals to q2 equals to q divided by 2. They will equally distribute the output between themselves. So A minus C by 4 will be the output by each firm. And in this case, if q equals to A minus C by 2, price will be equal to A minus C by 2 equals to 2A minus A plus C divided by 2. So it will be A plus C by 2. And what will be the profit? Profit will be P minus C into, profit 1 will be P minus C into Q1, and profit 2 will be P minus C into Q2. So in both cases profit will be same. So pi 1 will be equal to A plus C by 2 minus C multiplied by A minus C by 4. So what will be this? It will be A minus C by 2 multiplied by A minus C by 4. So A minus C whole square by 8. So we can write that firm 1 and firm 2's profit will be same whenever they join hands with each other and they will distribute the market share, they will divide the market share equally. And see, in this case, competition, in case of collusion, each will enjoy A minus C square by 8. In case of competition, what we see? We will see pi 1 equals to pi 2 equals to A minus C square by 9. So in this case, profit is A minus C square by 8. In competition, profit is A minus C square by 9. So in this case, it is always better for the firms to go for collusion. So their best policy should be the firms should cooperate with each other. But in reality, if we consider this game is played for only one time, if this is a single shot game or one shot game, this will the final equilibrium will be here. This will be the Nash equilibrium. This we will discuss in our next part.